In this video, I'll show you how you can implement refresh tokens that you can use to exchange for a new access token, improving the overall authentication flow. We're also going to discuss how refresh tokens improve the user experience and increase the security of your system. Let's start with a typical example of authenticating a user with our system, where the user specifies an email and a password. We validate if a user with a given email exists, verify their password, and then we issue an access token. This is going to be a JSON web token in this example. If I go into the create method, you will see I have a pretty standard implementation for creating a JSON web token. And what I want to focus on is the expiration time of the JSON web token. I'm controlling this through the application settings. And if I take a look at the value that I have right now, the expiration time is 10 minutes. We could make this even shorter if we wanted to. It could be 5 minutes or even 1 minute. Now, what is the purpose of this? We want the access token to have a limited lifetime, because an access token can be used to do pretty much anything inside of our application, or at least perform the set of authorized actions for a given access token. Now, if we make the lifetime of the access token relatively short, we can improve the overall security of our system. The downside is we have to somehow be able to generate a new access token when it expires. We could log out the user and have them go through the login use case again, which means they have to provide an email and password, and then we can return a new access token. However, we can also introduce the concept of a refresh token. This is a randomly generated value. It could be a string. It's going to be a string in the example that I'm going to show you, and we're going to implement support for exchanging this refresh token for a new access token without having to provide the user's credentials. So let's start by defining a refresh token type. I'll add a new class inside of the users folder, and I'm going to call this a refresh token. So I'm going to define a few properties on the refresh token. I need a way to identify my refresh token in the database. I also need a string property to be able to specify the actual refresh token value, and then I need a way to associate a refresh token with a given user. So I'm going to have a user ID as a foreign key inside of the respective table in the database. Now I also need a way to determine when my refresh token expires, and this lets you do a couple of things. First of all, we can define a lifetime for the refresh token as well. And secondly, we have an option to expire refresh tokens because we're storing them inside of the database. Now, one more thing I'm going to add is a navigation property for the user that owns this refresh token. And I'm just doing this to simplify some of my EF core queries. Then I want to be able to configure this with my database context. So I'm going to create a strongly typed configuration class, and I'm going to call this the refresh token configuration. It's going to implement the iEntityType configuration interface. I'll specify refresh token as the entity, and then let's configure a couple of things here. Let's start by defining the key for this entity, and this is going to be the identifier of the refresh token. Then I want to define a limit for the length of the token property. So let's say that the max length of the token is, for example, 200 characters. Then I'm going to define an index on the token property, and this part is optional, but if you want to have unique refresh tokens, it's definitely needed. And I'm just going to say that we have a unique index on this column. And then I'm going to say that the refresh token has one user, and this is going to define my relationship between these two tables. The user can have many refresh tokens, and the foreign key is the user ID property on the refresh token instance. Then I will go into the database context, and I'm just going to define the refresh tokens database set. So I'll say refresh token, and I'm going to call this refresh tokens. And I think we are ready to generate our database migration. So I'll say add migration, create refresh tokens. And this is going to produce an EF core migration that's going to create a refresh tokens table in the database containing the columns that I need to implement support for this. We're also going to create the respective unique index and the index on the foreign key columns to speed up queries. So this is going to run when I start my application, and I can close this down. Now what I want to do is to somehow return a refresh token when I log in my user. So let's go into the token provider, and I'm going to define another method here. I'm going to say public string generate refresh token, and what do I want to do inside? I want to return a base 64 string, so I'm going to say convert to base 64 string, and this accepts an array of bytes. And I'm going to use the random number generator to obtain a random array of bytes and let's say I specify that the length of this array is 32 bytes. The benefit of using this approach is that the generated array is going to have a cryptographically strong random sequence of values, and this is just to reduce the chance of collisions, and I also want to make the refresh token entirely random. So let's go back to the login user use case, and let's say I want to return a refresh token, but I don't have a strongly typed response. So I'm going to create one. It's going to be just a record, and I'm going to have an access token, and this will be the JSON web token value, but we're also going to return a refresh token. So let's update the handle method to return the response, and here we're going to say new response, pass in the access token, and what about the refresh token? Well, I could say token provider generate refresh token and be done with it, but what I actually want to do is to store the refresh token as a new row in the database. So let's create a refresh token entity, and I can say new refresh token, and we already have the user instance, so I can grab the user ID. We can generate a new value for the identifier of this refresh token. For the actual token value, well, this is where the method on the token provider comes in, so I can go ahead and use that value. And for the expires on, I'm going to just say datetime UTC now, and let's for example add 7 days to the current UTC time. Then I can use the database context to add the refresh token to the respective database set, and finally I can say save changes async, and then I'm going to return the refresh token value as the response. So yeah, this is all there is to it. Now let me go start the application, and let's observe the response from authenticating the user. So I can go ahead and send a request to the login endpoint, and we're going to get a response containing the access token, and this is the value that we use to authenticate our API requests. So now I can go ahead and grab the access token, pass it in the authorization header, and when I call a secured endpoint, I'm going to get back a response because I'm able to authenticate by providing the JSON web token. But we also have the refresh token here present in the response. This is just a randomly generated value. So how do we use this refresh token? Now we need to build an endpoint that's going to look like this, the login user with refresh token, and I should be able to take the refresh token value, paste it in the request body of this new request, and when I send this to my API, I should get back a new access token and refresh token pair. Of course, we're going to validate if the refresh token exists and if it's expired, and if we pass the precondition checks, then it's safe to return a new access token. Now, what is the point of this? We said that the access token has a relatively short lifetime. I changed it to be just 10 minutes. So what would happen in a client-server setup is we send a request to the API, and we get back a 401 unauthorized response, meaning that the access token has expired. So we're going to use the refresh token, which has a much longer lifetime, and exchange it in the background for a new access token and refresh token pair, and then we're going to retry the failed request with a new access token. So the overall user experience is improved because the user isn't aware of the access token expiration. They don't have to be logged out and be forced to log in again, and this also reduces the surface area for attackers to steal an access token because it has a short lifetime. Now if they manage to access a refresh token, that could be a problem, but then you can just revoke the refresh tokens for the user and you're back in safe territory. But let's go back to this endpoint and see how we're going to implement it on the backend. So I'm going to add a new use case in the users folder, and I will call this login user with refresh token. So I'll make this an internal and sealed class. For the dependencies, I need my database context, and I also need the token provider. What about my request? Well, this is going to be a public sealed record. We're going to call it request, and the contents of the request are just going to be the refresh token. For the response, I can copy what I already have in the login user use case, and this is going to be an access token and a new refresh token. So after we use the refresh token to obtain an access token and refresh token pair, we're going to generate a new refresh token. Then let's create a public async method returning the response. Let's call it handle, and the argument for this method is the request. So how do we implement this? Well, we obviously need to grab a refresh token, and I can say await context refresh tokens. I definitely want to include the user because I will need the user to generate an access token. And then I can say first or default async, where the token value is equal to the request refresh token. Then if the refresh token is null, or the refresh token expiry date is less than the current UTC time, then we're going to throw a new application exception and we're going to say the refresh token has expired. Otherwise, we can go ahead and produce a new access token. I can use the token provider to call the create method and pass in the user that I have as the navigation property on the refresh token. Now, when it comes to the actual refresh token value, we can use the same row in the database and just update the token value, but I also need to update the expiration time. So I'm going to say datetime UTC now, add days, and let's also add 7 days. Of course, I have to persist these changes in the database, and then I can return a new response and pass in the access token and the refresh token value. I'm also going to expose an endpoint that's going to accept the request and execute my use case, giving me back the new access token and refresh token pairs. One more thing I need to do is to register this with dependency injection. So let's say login user with refresh token, and now I should be able to just start the application and test out my flow. So we already have the refresh token from our previous API request. It's currently valid in the database, so I should be able to send this request and hit the breakpoint inside of my use case where I'm going to attempt to retrieve the refresh token from the database, which you can see succeeds, and this is the actual refresh token value. And then we're going to check if the token is expired, which it isn't because it's valid for 7 days. So now I can get a new access token, generate a new refresh token, overriding the previous one, which means I can no longer use it for future requests. Then we're going to persist this in the database and return a new access token and refresh token pair. Now let me go ahead and save the new refresh token value, and I'm going to send a request with the old refresh token, and we get back a 400 bad request. So the refresh token has expired and we can no longer use it. But if I paste in the new refresh token, I can go ahead and send the request and get back a new access token and refresh token pair. So this is how you can continue recycling refresh tokens to exchange them for new access tokens. It's a best practice to always generate a new refresh token whenever you call this endpoint. I've seen some implementations that reuse the existing refresh token, but this might leave you open to security vulnerabilities. So I just play it safe and I always generate a new refresh token that the client can then store locally and reuse in the future when they need to obtain a new access token. Now there's one more thing that we should be able to support, and that is being able to revoke refresh tokens for a given user. Let's say I go to the login endpoint and I authenticate a couple of times. Every login attempt is going to insert a new refresh token into the database. So I might end up with many refresh tokens where I'm only using one of them, the last one, for the refresh token endpoint, which means that we have a bunch of refresh tokens in our database that might remain unused. We definitely want a background job that's going to periodically scan the refresh tokens table, and that table will look something like this. You can see we have a bunch of refresh tokens for a single user, which I'm using for testing, and all of these are valid access tokens until they expire. So we want a background job that's going to clean up any unused refresh tokens. But one more thing you could consider implementing is always forcing the refresh token endpoint to check for the latest access token. If the user uses an older refresh token value, you can treat this as a security issue and force the user to authenticate again while also revoking any existing refresh tokens. You can implement this from this use case here, where you retrieve the refresh token. We can also check if there is an existing refresh token with an expiration time that is in the future, which means that there is a newer refresh token than the one we are trying to use here. But what about revoking refresh tokens? Well, let's create another use case that I will call revoke refresh tokens, and let's see how we're going to implement this. I need to access my database context so that I can interact with the database. And I'm also going to inject the HTTP context accessor because I want to validate who is the current user. So let's create a handle method that returns a Boolean value. And let's say that the argument is going to be a user ID. Now, how I'm going to use this is say context refresh tokens, where the refresh token user ID is equal to the user ID argument, and then I can say execute delete async. I don't need to load the refresh tokens into memory, as this approach is going to be more efficient. I can also expose an endpoint. There's going to be a delete endpoint, allowing me to revoke the refresh tokens for a given user. But the reason I injected the HTTP context accessor is to be able to perform resource authorization. I'm going to add a helper method. This helper method will allow me to get the current user's identifier, and we're going to grab this value from the user's claims using the current HTTP context. So what I want to do here is say if the user ID that is specified as the argument is different from the current user's ID, then I'm going to throw an application exception saying that you can't do this. So just a simple error message, I don't need to be specific. I will need to enable the HTTP context accessor as I haven't used this before. So I'm going to say add HTTP context accessor, and then I can start my application and test this out. So what I want to do now is to authenticate with my API again and get back a new refresh token that I'm going to copy and store locally. If I check in the database, you will see that there is one additional refresh token that can be exchanged for a new access token and refresh token pair. And then I'm going to call our new endpoint for revoking a refresh token. So let's go ahead and click the send button, and we're going to land on this breakpoint. And I'm going to first check my precondition, which passes, and then I can go ahead and execute my refresh tokens. So I'll say continue. If we check the database, you will see that no refresh tokens are currently present because we deleted them all. And if I try to log in with the refresh token that I previously stored, you will see that I fail because the refresh token has expired. And this is how we can easily revoke refresh tokens in case of any security issues, which will cause the users of our application to have to re-authenticate using the normal authentication flow. First, if you are enjoying this video so far, make sure to smash the like button under this video and subscribe to my channel. And second, if you don't want to implement support for access tokens or refresh tokens yourself, you could also use ASP.NET Core Identity. It has the ability to store user tokens in the database, and one of the use cases for this is to be able to store refresh tokens. So you wouldn't have to implement a new table and generating a token. ASP.NET Core Identity can take care of that, and you can just fill in the couple of missing functionalities. And if you don't want to deal with authentication yourself, then you can go ahead and use a robust identity provider like Keycloak, so you should watch this video next. Check out my courses to improve your software architecture skills, and until next time, stay awesome.